Guys, so I'll be explaining to you the dynamic programming solution to longest palindromic substring. This is actually a pretty easy problem because of the restriction that the size of S will be less than or equal to 1000, meaning that an ON squared solution will suffice. In this case, I will be describing the DP or dynamic programming solution because I believe that's the easiest to understand. So in this case, the dynamic programming part is using this function is palindrome, which checks a substring of S from I to J and determines whether it is indeed a palindrome. So how do we know if a substring is a palindrome? Well, okay, so this is the DP part. So if you have computed it before, then we just return the answer. Then if the substring is of size 1, then it's definitely a palindrome. If it's of size 2, then if the left and right characters are the same, then it's a palindrome. If not, then we check if the first and last character are the same. If that's true, then we check whether the center part, excluding the first and last character, is a palindrome. If so, then the whole I to J will be a palindrome. If not, then it will not be a palindrome. So this is actually relatively easy to see. And then to analyze this DP component, we see that there's at most n square states, and each state has at most an O1 transition time. So all calls to the sum of all calls to is Paddy will be at most O(n) square. This also means that since later on we are going to be making O(n) square calls, then the amortized cost of is Paddy is actually O1. Okay, so how do we use this is Paddy function as like a subroutine? Well, first of all, this is the entry to our is palindrome method. We set this object specific variable to S so that the is Paddy will be able to reference it easily. Then we initialize our memo array. Then we keep track of our longest existing palindromic substring. So the first element will be the starting index, and then the second will be the ending index. So this here is an ON square loop, which checks every possible substring, so every possible I to J where I is less than J in the string S, and then we will check if that substring is palindromic, and if it is, then we take it if it's longer than our longest possible existing palindrome. So we do that for all possible substrings, and then we return the substring that we have found. That's actually about it. So yeah.